I shouldn't have to be doing this, so please listen carefully. What is due east and due west? No matter where you're at on Earth, except the North and South Pole, you have a due east and a due west point on your horizon. That point marks the intersection of your horizon with the celestial equator. So on equinox, the sun rises due east for everybody, okay, which is a geodesic. See, look here, due east. One, the sun is on the celestial equator at equinox. Two, the celestial equator intersects your horizon at points due east and due west. Okay? Now look, a geodesic is also a great circle. Blue Marble Science is like the only glober I've talked to who knows this. Great circles are straight lines in spherical geometry. Okay? I shouldn't be having to go over this, but this is what it takes. A geodesic is a great circle or a straight line. Now, in this previous video debunking sunrises in Australia, how the sun couldn't come in from the south on a globe, I traced a longitude and a latitude line over Sydney, I believe, on the coast of Australia. Okay, I was showing that the sun could come in maybe a degree or two south of east, but not the way SunCalc shows it. But everybody quickly reminded me that our line of sight is not following the latitude because it's curving around the ball. Everybody quickly reminded me that my line of sight is actually converging at the equator, allowing the sun to come in more southerly. And now all of a sudden everybody's forgot that. So whether you agree with this argument or not, I'm not sure anybody even understands it. So I'm trying to be hyper detailed and hyper specific here to get this argument out there, because it's simple, but I don't see a way around this for them. So due east is a 90-degree turn on a globe, period. If you take a 90-degree turn from the north or south pole, you're going to get a geodesic or a great circle. There's no getting around it. If you just was standing on the North Pole and took a 90-degree turn, if you're facing a direction, it's going to give you a longitude, a great circle. If you go down to the equator and take a 90-degree turn, it's going to give you a great circle. Okay, if you're on the North Pole and you go down 30 degrees and take a 90-degree turn, it's not going to follow the latitude. It's going to veer and converge toward the equator and give you a great circle. There's no getting around this. The equinox is a moment in time when the sun crosses the Earth's equator, which is to say it appears directly above the equator rather than north or south of the equator. On the day of the equinox, the sun appears to rise due east. So the meaning of this is very, very important. If I'm standing on the equator and I'm looking due east, I'm looking along the equator. If I have a laser beam coming out of my eyes and it could wrap around the globe due east, it would wrap around and come and zap me in the ass. I hope everybody understands this. So I have shown, I have defined, and I have demonstrated that due east on any sphere is a great circle. So if I'm standing at 30 degrees north looking due east with laser beam eyes, and the laser could bend around the globe, it would zap me in the ass. Okay, now we've all heard them tell us that if we're standing at 30 north, for instance, and we're looking due east, our line of sight is not going to stick along that latitude line because that latitude line is going to bend around a sphere. But they cannot bend or pervert a straight line of sight great circle. All they can do is say that it's rising off the ground, but that does not change the angle. So if you're standing at 45 degrees north latitude looking due east, you're angled away from the equator. So your east is not going to follow that latitude line because of your angle. It's going to be converging toward the equator. So I went to Google Earth and I showed that from 30 north and 20 east approximately, due east converges at the equator approximately 6,200 miles away. In the Philippines to be exact. So our straight line of sight from 30 north converges 6,200 miles away in the Philippines, and the same thing from 30 south. And I zoom in to show you that each one of these lines is due east. So simultaneously, from 30 north and 30 south, we have straight lines of sight converging 6,200 miles away in the Philippines. Now, they can say that our laser beam is is rising above the ground, above Earth, but they still converge. They still have a problem. That doesn't stop them from converging at the equator. So a brief but very important summary of this video. These two lines, one of them obviously stitched in, but they represent great circles, which are straight lines on a globe, straight line of sight. If you continued them, they'd wrap around on themselves. That's all Google Earth will let you draw are great circles. So this would be the summary of all summaries to all the trolls who use the excuse, you don't understand 3 dimensions. You know, I'm going to give you amnesty on this one because they probably had you confused warping lines of sight and shit. So I've used straight lines of sight. So this represents a geodesic straight line of sight. So there's no bending and warping. And I want you to follow me on this last exercise here. We're at 30 north and 30 south, looking due east on the equinox at a sun that's barely above the horizon. We're looking basically at a tangent. And our laser beam eyes turn on. Okay, now with the sun just barely over the horizon, the Earth just disappears out from underneath us. All right, so it doesn't matter where the Earth winds up. We're in free space now. Our laser beams are going to cross at 6,200 miles. So this totally debunks a 93 million mile sun.